Welcome to section 1.7. Today's going to be all review of the definitions of inverse trig functions and their calculus. So let's just jump right in. If we want to evaluate inverse trig functions, we need to remember that they have restricted ranges, which I have in these red boxes above. So on this first one, if we want cosine inverse of -1/2, well, why is cosine inverse of -1/2 if and only if take cosine of both sides, cosine of y is -1/2, and the important part is that y has to be an angle between 0 and pi. So, and y is in the interval from 0 to pi. I like to do it graphically, like this, but you could also write y between 0 and pi. All right, now instead of infinitely many values of y whose cosine is -1/2, there's only one. And this just requires knowledge of the unit circle. Y is 2 pi over 3. And that's our answer. All right, maybe you should pause the video and do the next two. Hopefully you did that. This next one, we take sine of both sides. Sine of y is -√3 over 2. And y has to be an angle between -pi over 2 and pi over 2. All right, well, that narrows it down. Y is -pi over 3. And you might say, well, that's true, y is -pi over 3, but what about 5 pi over 3? That shares a terminal side with -pi over 3, and sine of 5 pi over 3 is indeed -√3 over 2. The problem is that 5 pi over 3 is not in the interval from -pi over 2 to pi over 2. So that would not be a valid answer. Okay, and last one, before we can find y, we need to clean this up. We want tangent inverse of tangent of pi. Tangent of pi is 0. So tangent of y is 0. And y is an angle, I'll switch notations, between -pi over 2 and pi over 2. So y is the angle 0. Okay, derivatives. We memorized these last semester. Here are the derivatives for the 6 inverse trig functions. The second column you get for free because the second column is, if you look at these formulas, these are the same as the formulas in the first column except with a minus sign. All right, let's take some derivatives. Here in the formula for the derivative of sine inverse of u of x, my u of x is 2 minus x. So y prime is u prime, which is -1, over the square root of 1 minus u squared. And that's 2 minus x quantity squared. And I could multiply that out, but I think it's a lot cleaner just to leave it the way it is. The next two we will simplify. Okay, the next one, derivative of tangent inverse of 4x cubed. So now I'm using this formula, u prime over 1 plus u squared, y prime. U prime is 12x squared, and then 1 plus u is 4x cubed. And I want to square that, and we wouldn't want to leave our answer like this. It only takes a second to clean it up. 1 plus 16x to the 6. Okay, and lastly, y prime, same formula. We want u prime on top, 2e to the 2x. And on the bottom, we want 1 plus e to the 2x squared is e to the 4x. You have an exponent to an exponent, you multiply the exponents. Okay, the sister formulas for the derivative formulas are the integral formulas, and these come straight from your integral Bible, so let's just jump right in and do 3 examples. The first one is a tangent inverse, and my k in this case, if we look at this formula for your Bible, the k is 5. So this is equal to 1/5, not arrow, but equal 1/5 tangent inverse x over 5. straight bar, -5 and 5 root 3. That's 1/5. Pull that out. I want tangent inverse. When I put in the upper limit, I just get root 3 minus tangent inverse. When I put in -5, I get -1. So that's 1/5. Tangent inverse of root 3 is pi over 3. Tangent inverse of -1 is -pi over 4. So if I get a common denominator inside there, that's 7 pi over 12. So my final answer is 7 pi over 60. Okay, the next two require a little bit of massage. So this looks closest, this problem here looks closest to a sine inverse from my Bible, but the problem is I have a 2y squared, not just a y squared. So this requires a u sub. I'm going to let u equal 2y, and you'll see why in a second. Du is 2 dy. Well, I don't have 2 dy, I have 1 dy. So 1/2 du is dy. So my integral is 1/2, I'll pull that out front. Du goes here, and what's left is 1 over the square root of 36 minus 4y squared is u squared. That's why I made that u sub. Now I can use the formula from my Bible. And I wanted to mention one thing. Of these three formulas, there's only one without a 1 over k out front. The other two have a 1 over k out front. And the one without the 1 over k out front is sine inverse. So this one, we're not going to pull out a 1 over 6. This is just going to be 1/2 sine inverse of u over 6 plus c. And now we back substitute to leave our answer in terms of x's. And so this is 1/2 sine inverse of 2y over 6 plus c. Finally, clean that up. 1/2 sine inverse of y over 3 plus c. Okay, why don't you try one? Pause the video and do this. This is a definite integral, so you want to change your limits. Okay, hopefully you did that. I'm going to let u, very similar to the one above, u is going to be 2x, so I can use this Bible formula. Du is 2 dx. I have 4 dx, so 2 du is 4 dx. So this integral is twice integral du, and what's left is 1 over 1 plus u squared. And let's change our limits. When x is 0, u is also 0. And when x is 1/2, 1/2 times 2 is 1. So that's my new integral with new limits. And I'll evaluate. This is 2 tangent inverse of u, because our k is 1 in that formula. Straight bar, 0, 1. So that's twice tangent inverse of 1 minus tangent inverse of 0. Tangent inverse of 1 is pi over 4, and tangent inverse of 0 is 0. So pi over 2. Okay, quick section, but very useful, and that's the end.